Look this up. In 2 unit, there's plenty of questions on Locus, okay? But I didn't find a single one with a restriction on the domain like the kind we're going to talk about today, okay? It does appear in 3 unit sometimes, because these restrictions, they often have to do with the parameter, right? So parametrics, and so that's a 3 unit topic only, right? So they sometimes appear, but when they do appear, it always says, find the locus, okay, find the equation of the locus, and state any restrictions on the domain, okay? So they give you this big red flashing clue to say, look, there's going to be some of these and you'll need to find them, okay? If you go into the 4 unit maths exams, that's where you get these and they just expect those guys to work it out, okay? So even though these might be a bit tricky and the methods I'll show you there too can be quite confusing, if you need to use them, they'll tell you, okay? So let's start by just redefining what's a locus. Okay, can anyone give me like a 1 sentence or like a 1 phrase definition? A locus is what? Good, good. It's a set of points. And it's not just any set of points, right? What's the quality that unifies all of these points together? Good, good. So whichever way you say it, either satisfies or behaves according to or whatever, there's some geometric rule or geometric property that all of the points exhibit, right? Okay. Now, usually we would say, well, let's actually do an example, okay? Draw yourself up a little set of axes, okay? And we'll pick a super simple example, one of the first ones that we did. If I gave you 2 points, okay, like say A, let's say that's 1, 0, okay? And let's put B, I don't know, somewhere up here, somewhere boring, like 1, 2. Okay, now if I said, what's the locus of all the points that, now I'm going to give you the property, okay, which are equidistant from A and B, okay? Not an equation, how would you define that? How would you describe it in words? What is the locus of those points? Equidistant from A and B. A line, which line is it? It's a specific line. Good, good. So if we join this interval, okay, the locus that I'm interested in is the perpendicular. It's not quite a bisector, but I'm just going to call it bisector. Perpendicular bisector of that interval AB, okay? But because that's a bit of a mouthful and it's not always such a convenient sort of line, we usually give an equation, right? So the questions you get are, what's the equation of the locus? And the equation in this case is?
Y equals 1.
Thank you. Okay, now, the important thing to get is, when you're doing, I think I just drew myself. When you're doing a locus, right, you'll get this equation. But this equation, right, and what did we say? The perpendicular bisector, right, of AB. This thing is the locus, okay, this red thing. And this is the equation of the locus. But they're not the same thing, okay? They might signify the same thing, but they're not always exactly the same. Now in this case, they are, right? But where they're not, that's what this is about, okay? So let me try and segue into it and explain why we need restrictions by drawing your attention back to one of the earlier derivatives that you learned. If I gave you this function, okay, you would say that dy and dx is equal to?
1.
Good. Okay, now again, for the sake of argument, right, let's just quickly draw this thing. Log x, what does that look like? That guy, okay? That's got an asymptote at this axis. Now, what does this look like? Everyone does the motion with their arms, good. So you're getting, sorry, I did it backwards. You're getting this kind of shape, right? Now, straight away, you can see there's a problem, right? If this is our function, and I want its derivative, okay? The equation of the derivative and the derivative, just like the equation of the locus and the locus, they're not the same thing. What's the difference? What's the difference between the derivative and its equation?
The equation gives you an extra bit.
Yeah, that's right. It gives you stuff over here, a derivative where the graph itself doesn't even exist, okay? So you can see the equation is not the same as the derivative because there's a part which doesn't matter, right? In other words, there's a restriction on it. Okay, what is the restriction in this case?
0.
x is greater than 0, right? That's totally what you meant to say, right? Okay, so that's why when we're doing locus, okay, you're going to do all your work and you're going to come up with some equation, okay? Sometimes it's fine. But other times, like here, right, you're going to have to say, well, sometimes it's this equation and other times that doesn't make any sense, okay? So